Hello everyone, welcome to this session on Introduction to Statistics. And this is our session number 21, right? Yeah. So we are discussing about the different methods of finding mean. Like we are finding the uh, measures of central tendency for group data, right? So here in this session we will be focusing on the third method of finding mean for a group data, that is called step deviation method. Okay, so these methods, the alternative methods are all the extended version of the step like a direct method, right? So our, like, why we are moving to one method to another method, the core reason behind moving from one method to another method is to make the calculations very simple. That's all. So this is the core reason, right? So in the direct method, I'll just briefly just go through the previously learned things. Okay, so in the direct method, so what we have done in the direct method, so we have already these data, so class intervals and the frequency. So in the direct method, we found the class marks, then we took the product of these two, right? So then we use the formula mean is equal to sigma fi xi divided by sigma fi. So this is nothing but the sum of all the observations divided by the total number of observations. That is fine. So then we thought that if these numbers fi's and xis are large, right? So then obviously the product of these two numbers is also going to be large, right? Then our calculations will become, so when you are taking the product and taking the sum, that will become tedious, right? So obviously when the numbers are very big, so they are time consuming, right? So then we thought, so instead of taking the direct product of f and xa, let us make some changes in the xa value, right? So for that, what we have done, we have taken the class intervals, then we have already the frequency, then xi. So then we started making changes in the xi. So what we have done, we wanted to calculate the deviation, right? How we can calculate? We assume one assumed mean, that is called a. So this a is coming from the one of the class mark. As I said, generally we prefer this a as a middle number, middle of class mark. So I told you, right, the benefit of taking the a from the middle class marks, right? So then instead of xi, so then in the fourth column we have taken the FIDA. So we have already seen that when you are taking the product of F and DA, so the calculations become very simple compared to the previous direct method, right? So now, so this method is called assumed mean method, right? Assumed mean method. So now here in this session number 21, what we are going to do, so we are going to further reduce. So will make it more simple. So what we do, we will keep these CA class intervals and FIs and XIs and DIs also. So these are all the numbers we are getting from the previous methods only. The only thing is that we are extending from one method to another method to make the things very simple. So now here, after having di, so we want to make it further. So what I will do, I will take a number called u. So what is this number u? Is nothing but you divide this di, the deviation you found, right? You divide that deviation with the class size, right? So then instead of finding di, now you take the product of f and ui. So that is a so that is called a step deviation method, right? So essentially, so the mean formula to find from the step deviation is, so we are going to use this a as the same, the assumed mean, and we are making only changes in the second part. What is that second part? So we are going to take the sum of the product of these fi ui and divide with the sigma fi, and this number is multiplied with a called h is nothing but the class size. Clear? So this is called a step deviation method. Okay, so let me show you how we can do the things in the uh, let me show you clearly. Okay, so for that, so we let us take the table. Okay, so let me insert the table. Okay, so bring the table here. Okay, yeah, so our numbers will remain same. So the first column is class interval, so that will remain same, and then next we are going to keep as a number of students, so that is nothing but a frequency, right? So that is denoted with the fi, and the third column class mark, so that is denoted with the xi. Okay, so then we have di, the deviation from the assumed mean, right, of the each observation, so that is xi minus a. So now here the fourth part comes now, so the step deviation. So here instead of taking the da, what we are taking the number called ui. So how we will define ui? As we just divide this deviation with the size, class size, right? So then we take the multiplication of fi into ui. Okay, so ui, so that is the so let me delete the column. Okay, so delete the column. Yeah, so now here the class intervals 10 to 25, the first class interval, and the second one is 25 to 40, and 40 to 55, 55 to 70, and 70 to 85. Okay, so let me insert another row. Okay, so actually we need to insert one more row. Why? Because if you remember, so we are taking the sum of the frequencies as well as the sum of the product of the last column, right? So for that purpose, so here the 85 to 100. Okay, and these number already given 2, 3, 7, 6, 6, 6. Okay, so these class marks, right? So we already find, right? So I'm not going to repeat. So if you already know, right, how to find the class mark, you just take the sum of the lower limit and upper limit divided with the 2. So here the first one is 17.5, and then 32.5, 47.5, 62.5, 77.5, and then 92.5. So these are all the class marks, and we have already the deviations from the previous method, assumed mean method, right? So this is minus 30, sorry, minus 30 it is, and then minus 15, 0, right? So now this is the added advantage. So here, so if you remember, what is our a? So we have taken a as this, right? So this is our a, 47.5, right? So why? Because if it is already 0, so then the next the another side of 0 you will be getting the positive numbers. So that is 15, 30, and 45, increment of 15, right? So that's how we'll do. So now here comes the step deviation method. So now how you will find the class size, right? So here this h represents the class size. So how we will find the class size for a given class interval? You consider any class interval, let's say here 10 to 25, right? So we know that this is the lower limit and this is the upper limit. So how we will find the class size? Class size is nothing but the difference between the upper limit and the lower limit. Okay, so here it is 25 minus 10, which is equal to 15. So generally whenever you have continuous class intervals, so the class size will remain same throughout the class intervals. Okay, so here h is 15. Okay, so that is going to be 15. So now you just divide these all di's with this 15. So minus 30 divided by 15, so how much it is? Minus 2, right? So our di is how much? Di is minus 30, so divided by 15, so which is equal to minus 2. And similarly minus 15 divided by 15, so that is minus 1. So 0 upon 15, 0, and so on. If you do divide with all these di's with the 15, right? So this is going to be minus 1 and 0, this is going to be 1 and 2, and this is 3. Okay, now you see here, if you clearly you can see earlier the numbers. So okay, let me complete this column, then we'll make the conclusion. Okay, so now here the you just take the product of fi and ui. Okay, so these are all the fi's and these are all the ui's. Okay, so you just take, so it is going to be 2 into minus 2, minus 4, minus 3, 0, okay, 6, 12, and 18. Okay, so this is the done. Now you see what I want to say is that till here it is a direct method, right? So now here, now you see these are all the numbers with the decimal numbers. So multiplication of this number fi with these decimal numbers, it takes time. It is, I'm not saying that it is a complex, but it takes time. So we want to reduce our time towards our calculation. So therefore, so what we have done, we have taken the deviation, assuming the a as a assumed mean, and we took the difference, how much deviation there from the each observation, right? So then these numbers are pretty much easy to multiply with these frequencies, right? So then further, so till here it is the assumed mean, this is the assumed mean. Okay, so now further what we want to do, we want to reduce further, so therefore we are dividing these all deviations with the class size. Okay, so then you can see these numbers became reduced, right? So the further, so then taking the multiplication of this fi with the single digit numbers becomes more easy. Okay, so in the final, so we wanted to take the total, and this is the sum of all the observations. We know this is 30, and then we want to take the sum, right? So the sum of fi ui, so how much it is? If you take the sum of these numbers, okay, so the number will be 29. Okay, so now we are done, with the table. So now here we are moving to the final conclusion to find the mean. So mean x bar is equal to, so this is our formula in the step deviation method. What is the formula? A plus sigma fi ui divided by sigma fi, then multiply with the class size. Okay, so therefore a is how much here? 47.5, right? 47.5 plus sigma fi ui, so how much it is? 29 divided by sigma fi, so that is 30, and then multiply with the class size, that is called a 15. Okay, so if you further simplify this, okay, so further simplify this, so 47.5, and also if you simplify this number, okay, so you would be getting for 14.5. Okay, So you are getting again the same number as a 62. Okay, so therefore, so the mean x bar is equal to 62. Okay, so now if you see clearly, to find the mean, to find the single measure of central tendency, so here specifically we are talking about the group data, right? Right, so as I said, whenever if you want to find the mean, so there are three methods are there. So direct method, right, and assumed mean method, and then we have third one, step deviation. Okay, so if you see in the three sessions, we observe that we are getting the same mean, xt2, sorry, 62, right? So therefore conclusion is, you use any method to find the mean. You can use a direct method, you can use assumed mean method, step deviation method, you can use any method of your choice, you would be getting the same answer. Okay, so that is x is 62. So the only thing is that we are choosing one over the other because of tedious calculation, to avoid the tedious calculations, right? So therefore we wanted to save our time, so therefore what we do, we prefer the method which is taking the time for the calculations, right? So the only and one more thing, after see we are moving to one method to another method, that is fine, but if you don't remember the formula, then it will become very difficult. Suppose if you don't remember the formula of assumed mean and step deviation, so it is very difficult to get the answer. So therefore, and remembering those formulas is also very simple. So the core concept behind the mean is same, sum of all the observation divided by the total, right? So therefore in the direct method, what we have done, sigma fi xi by sigma fi, and then instead of xi we replaced. So when you are replacing di, our calculations are becoming very small, right? So therefore what we have done in the assumed mean method, so we have taken the a larger number, that is assumed mean, so we assumed this mean and then we took the how much deviation, so that the deviation is covered in the second part. So fi di, then sigma fi, right? So we want to further reduce this di. So therefore, in the step deviation method, what we have done, so we have taken this a, instead of fi di, so we used fi ui, right? And then when we are using introducing ui, so then we are using the h, right? So the class size. So this is a very simple to remember the formulas also. Clear? So that's all for this session, and we are done with the mean for the group data. Okay, so thank you, and so I would request everyone to like and share and subscribe. Okay, thank you.